Now new chapter they are studying, which is current electricity. Current electricity. And current electricity branch will be electrodynamics. Till now, electrostatics, charges are rest done. Now we are entering into electrodynamics. Charges are in motion. Okay. In this में अभी से पूरा motion में चलेगा. Okay. Now first we'll see the definition of current electricity. The study of electric charges in motion is called as current electricity. The branch को we call as current electricity. And in this way, charges move with a constant speed. Constant. When the charges start moving with a variable speed, then the magnetism come into picture. Okay. Now the charges are going with a constant speed current. Okay. In this way, we are studying about some variables like current के बारे में. First we will learn about the current. Yeah. Electric current. You know, electric current means rate of flow of charges, right? Okay. देखो, the rate of flow of charge through which an area held perpendicular to the direction of flow of charge. Suppose it's a connector. So what is current says? Rate of flow of charge. Okay. So how much charge flowing per second is called as current. Okay. And that area should be held perpendicular to direction of flow of charge. That's what he's saying. Okay. So formula क्या होगा? Rate of flow of charge is I equal to Q by T. This is the basic formula, right? Rate of flow of charge. So how much charge flowing per second is called as current. And we know the units of currents. Units क्या होगा? Dimensions क्या होगा? Dimensions क्या होगा? Current का? Uh, this is one of the 7 fundamental quantity, right? So what will be
Ampere.
ampere only? Okay. कब बढ़ेगा तक? Okay. तो अच्छे से लिखो, फास्ट लिखो. Okay. Units क्या है? Units is ampere and dimension is m0, l0, t0, a power 1. The dimensions. Because 7 fundamental quantities में one of the fundamental quantities is ampere. Now here we have two types of currents. One is average current, other one is instantaneous current. Okay. Average current. Average current means suppose मान लो this is a cross section area. In this cross section area में मान लो delta Q charge is flown in delta T time. So then average current will be, we can define as delta Q by delta T. Delta Q is nothing but Q2 minus Q1 by T2 minus T1, or I can tell total charge flowing per unit time is called as average current. Total charge कितना flow किया in the cross section area में per unit time is called current. Other one is instantaneous current. Instantaneous current means suppose in a cross section area में dq current is flowing in dt time, differentiation वाला small charge flown per second is called as instantaneous current. dq by dt differentiation करना पड़ेगा. Okay. Now डायरेक्शन ऑफ इलेक्ट्रिक करंट, करंट का डायरेक्शन वेदर वी विल टेक इन द डायरेक्शन ऑफ इलेक्ट्रॉन्स और इन द डायरेक्शन ऑफ प्रोटॉन्स पॉजिटिव चार्जेस, विच डायरेक्शन वी विल टेक कन्वेंशनली, करंट डायरेक्शन किस तरफ लेगा, मतलब विल टेक अपोजिट टू दैट ऑफ इलेक्ट्रॉन्स और सेम डायरेक्शन दैट ऑफ इलेक्ट्रॉन्स, क्या है?
Same direction.
नो नो, सो पॉजिटिव चार्जेस किस तरफ फ्लो हो रहे हैं, उसी डायरेक्शन में द करंट विल फ्लो, ओके। इलेक्ट्रॉन्स का ऑपोजिट डायरेक्शन में द करंट विल फ्लो कन्वेंशनली, ओके। So we can tell conventionally we define the direction of electric current as the direction of flow of positive charges. Positive charges किस तरफ flow हो रहा है, उसी direction में the current will flow. Okay. Suppose in metallic conductor is there, the metallic conductor which we are seeing normally. Electrons suppose मान लो are flowing in this direction. उसका exactly opposite direction में the current will flow in metallic conductors. मतलब से नेगेटिव चार्जेस आर फ्लोइंग इन दिस डायरेक्शन मींस पॉजिटिव चार्जेस आर फ्लोइंग इन द ऑपोजिट डायरेक्शन, तो उसी डायरेक्शन में वी शुड टेक एज करंट, so direction of current is taken as opposite to the direction of flow of electrons in metallic conductors. Okay, now here in electrolytic conductors, इलेक्ट्रोलाइटिक कंडक्टर्स मींस सेल में होने दो, उसमें क्या होगा, आयॉन्स विल बी देयर, एग्जांपल कॉपर सल्फेट आयन Cu2 प्लस SO4 2 minus ions, both negative ions also is there, positive ions will be there, both will be moving in the cell में, right? Both positive ions negative ions will be moving. Suppose मान लो the positive charges are moving in this direction, that means the current direction will be taken in the same direction, right? Because of positive charge, positives are moving and negative ions are moving in this direction, matlab negative ions are moving in this direction means the current will flow in the exactly opposite direction to that of negative ions, that is negative ions की वजह से current आ रहा है. That means whenever in electrolytic conductors में we should take both current, we should take I positive charge की वजह से plus negative ions की वजह से, पॉजिटिव आयंस नेगेटिव आयंस की वजह से दोनों करंट को लेना पड़ेगा इन इलेक्ट्रोलाइटिक कंडक्टर्स. सो दिस इन दिस में करंट इज ड्यू टू द फ्लो ऑफ आयंस. ये वाला नॉर्मल कंडक्टर कॉपर वायर, हमारा जो नॉर्मल रेगुलर वायर्स है दैट वन, हियर दिस इज सेल में, इलेक्ट्रोलाइटिक सेल्स में. एंड चार्ज ऑफ इलेक्ट्रॉन मालूम है ना कितना होगा चार्ज ऑफ इलेक्ट्रॉन का, 1.6 इंटू 10⁻⁻, कितना,
19
19.
minus 9.
Okay. So this formula also will helpful for you. I is equal to Q by T, right? And Q is nothing but NE by T. Because total charge in the conductor is nothing but number of electrons into the charge. Total charge आ जाएगा NE by T.
So what's the direction of current in electrolytic conductor? Opposite.
इलेक्ट्रोलाइटिक कंडक्टर्स में आपको फर्स्ट ऑफ ऑल कभी भी नेगेटिव आयंस का ऑपोजिट डायरेक्शन में करंट विल फ्लो, राइट?
Even for
हाँ,
electron.
एनीथिंग दोनों में नेगेटिव आयंस का ऑपोजिट डायरेक्शन में करंट होगा, बट हियर पॉजिटिव आयंस आर फ्लोइंग इन राइट साइड, सो दैट्स व्हाई करंट ड्यू टू पॉजिटिव आयंस आल्सो विल बी देयर, एंड नेगेटिव आयंस आर गोइंग लेफ्ट साइड, उसका एग्जैक्टली ऑपोजिट डायरेक्शन में द करंट विल फ्लो बिकॉज ऑफ द नेगेटिव आयंस. बोथ करंट्स वी शुड ऐड इन दिस, बट इन दिस में क्या होगा, the positive ions will not move, right? Atom में, nucleus में positive charges are there, right? Whether protons will move from one place to other place, no, only electrons will start moving. That's why we'll take only for electrons का current only here. Okay, in this में both ions we should take. That's why I is equal to दोनों add करना पड़ेगा, I plus plus. चल No, is current is a vector quantity or scalar quantity? Vector or scalar? Right or left? Vector, scalar. बोलो.
Scalar.
You tell me. Scalar? Why? Direction है ना उसके पास. ऐसा. Suppose मान लो this is 3 ampere, this is 2 ampere. Angle is 30 degrees. So क्या होगा? 3 ampere, 2 ampere दोनों मिलकर कितना एम्पियर आएगा? How much ampere will flow here? 3 ampere is coming like this, 2 ampere is coming like this. So how much current will flow? अरे ऐड करो कितना? Mic testing 1 2 3. Can I able to hear? बोलो. 3 ampere, 5 ampere कितना current will flow here? इसमें 3 ampere, 2 ampere. Angle is 90 degrees. So how much current in this में flow होगा? Tell me. Angle is 90. सात्विक बोलो. बोलो नहीं बोल रहे हो. बोलो. देखो 3 एम्पियर 2 एम्पियर मिलके इसमें 5 एम्पियर विल फ्लो. 3 एम्पियर 2 एम्पियर मिलके 5 एम्पियर विल फ्लो. मतलब सी even though it has direction, okay, it is a scalar quantity. Current is a scalar quantity. Why? आपको डेफिनेशन ऑफ वेक्टर क्या है आपको स्टार्टिंग में दिया था मैं. वेक्टर सेटिस्फाई होने के लिए 3 कंडीशंस आर रिक्वायर्ड. वन शुड बी हैविंग डायरेक्शन, मैग्नीट्यूड एंड आल्सो इट शुड सैटिस्फाई वेक्टर लॉ ऑफ एडिशन. मतलब पैरेललोग्राम्स ऑफ सैटिस्फाई होने का. बट इधर देखो 30 डिग्रीज में 5 एम्पियर, 90 आल्सो 5 एम्पियर. So it is not following the vector law of addition. That's why it is not a vector quantity, it is a scalar quantity. So current is a scalar. Even though current has a magnitude and direction, but not satisfying the vector law of addition, that's why it is a scalar quantity. So we learned the formula I equal to Q by T or NE by T. This is a formula, right? चलो. Now थोड़ा chemistry भी इसमें डालेंगे. करो numericals. 0.5 mole of electrons flows in a wire of in 8 minutes. Find the magnitude of electric current. Avogadro number is this much, right? Approximately told to take. So current का formula क्या? I is equal to Q by T. So Q equal to Ne number of electrons into the charge of electron by T. N is 0.5 into how many number of electrons are there? 0.5 mole. 1 mole में इतना electrons, right? So 0.5 into 6 into 10 power of 23 into 1.6 into 10 power of minus 19 by 8 minutes. Always should be in seconds. So 8 into 60. Solve करो answer.
100 amperes.
Yes, correct. 100 amperes is the answer. Okay. Sure. So I'm not I equal to Q by T is the formula. Chalo. A solution of copper sulfate ions. Okay, this many ions are there, copper ions are there, this many sulfate ions are there. In 2 seconds में मतलब वो solution में इतना pass हो रहा है. Find the current passing through this solution. कितना current flow हो रहा है in solution. So here current is due to positive ions or negative ions.
Both.
Current will be both, right? So use karo. Current is asking it. Current due to positive ions plus current due to negative ions. So इसका Q by T plus magnitude I'm talking about. इधर भी Q1 a Q2 by T. Now, either Q1 means how much charge is that? Tell me. Q1 में कितना charge होगा? Copper ions मान लो Q1. How to find? Q1 charge, देखो, how many ions are there? This many ions, right? So first number, any, right? Normally, n कितना है? 10, 16 and 10 power of 16 into, okay, how many electrons are there? 2 plus ions, 2 plus ions, right? So 2 into charge of electron, 1.6 into 10 power of minus 19 by T. Okay, T is 2 plus, so मैं वाला Cu2 plus and SO2 minus में how many ions will be there? 2 electrons. का charge is 2 minus. 2 electrons are there. इधर भी 2 electrons are there. Okay. Plus इधर कितना होगा? Ne, right? N is 10 power of 16 into 2 into 1.6 into 10 power of minus 19 by 2. Solve.
So won't you consider the total number of electrons that are there in both the uh, given ions?
Total number of?
Electrons in both the ions. So the
Oh no,
atomic
both ions का total number of electrons find करने को. Total charge find करेंगे. इधर total charge how you got?
uh,
Number
6
of Ne, right? Ne, right? So n is or 16 10 power of 16 into E is this one 1.6 10 power of 19. How many electrons are there here? 2 plus, right? So 2 plus will be 2 ions will be two copper sulfate ions will be there, right? So dono charge we have to add. So 2 times multiplied. Okay.
So the total number of electrons would be 29 minus 2, right?
29 minus 2. Why 29 minus copper ka you're seeing?
Yes,
Copper
sir.
का atomic number ions we are talking about ions Cu2 plus ions. Okay, in that में charge we are talking about charge electron का charge है इसका charge कितना है 2 plus है ना 2 से multiply करने का. Okay, ion time में जो भी number है ऊपर उसका multiply करो charge we are talking about. Okay, not the number of electrons नहीं है. So this many because this many number of electrons are there, this many number of ions are there. Okay, so उसका charge multiply करो this 2 and इधर भी 2. कितना होगा आंसर?
1.6 into 10 power minus.
Yes, 16 milliamperes. Correct. So whenever ions come into picture, you should add for both the ions का current due to positive ions plus current due to negative ions. Normal wire में तो एक ही current है Q equal Ne by T. Okay. फाइंड करो. In a hydrogen atom, electron makes about this many revolutions per second around the nucleus. Determine the average current at any point on the orbit of the electron. So hydrogen atom में how many electrons are there? Hydrogen atom में how many electrons? Hydrogen में
1.
1 electron. So ये electron घूम रहे हैं, zoom 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 बोल के घूम रहे हैं. How many times? This many 0.6 and 10 power of 16 revolutions per second घूम रहे हैं. He's asking what is the average current. Fine. N is how much? So I is equal to at any point on the orbit of the cell. Suppose this point P mein, I want to find the current. How much current is flowing at any point on the orbit of the cell. Okay. I is equal to Q by T and Q equal to Ne by T. Okay. Tell me how many number of electrons are there? How many number of electrons are there in this? One. But वो rest में है क्या? Electron. Suppose if you see in this point where he's talking at any point on the orbit, right? So I'm seeing in this point where, okay, suppose you are sitting here, okay, you are seeing this one, okay, you don't know that there is one electron only, okay. In 1 second may how many electrons are coming out? How many electrons are coming out in this in this question mein? देखो
0.6.
0.6 in 10 power of 16 revolutions per second it is going, right? So आप इधर से देखने से this many electrons are coming out, even the one electron only, same electron only 1 second में उतना बार आएगा, right? So we should take n that many revolutions. So कितना होगा? 0.6 into 10 to the power of 16 per second में इतना electrons, you feel that same electron only that many electrons are coming out. Okay, into E क्या कितना है? 1.6 into 10 power of minus 19 upon per second, right? 1 second. So 1. Calculate लो.
96 into 10 power minus 5.
Yes. So I can write as 0.96 milliampere. Okay. Q equal to Ne by T. N कितना है? Number of electrons में 1 नहीं है. ये रेस्ट में नहीं है. एक सेकंड में वी आर टॉकिंग अबाउट 1 सेकंड में कितना चार्ज पास हो रहा है, कितना चार्ज पासिंग हो रहा है. यू डोंट नो दैट वन सेम इलेक्ट्रॉन ओनली, बट इफ रिमन रिवोल्यूशंस कर रहे हैं ना, सो इलेक्ट्रॉन्स आर कमिंग लाइक दिस. सो 1 सेकंड में नंबर ऑफ इलेक्ट्रॉन्स दिस वी आर पुटिंग दिस वन. समझ में आ रहा है? यस. चलो आना करो. Charge in terms of time is given to you. Find current I at t equal to seconds. At means instantaneous, right? Fine.
So 6 and 4.
6 and
4.
oh, very good, super. I instantaneous formula क्या होगा? dq by dt. Differentiation, right? So कितना होगा? T square का differentiation is 2t plus 2 will be coming outside. Differentiation of t is 1. So 2 at 2 seconds, right? So I at t equal to 2 seconds. So 2 plus 2, 4 amperes, right? 2t plus 2, 4 plus 2, 6. Okay. Now I average formula क्या है? Delta Q by delta T. Q final minus Q initial. How many seconds चाहिए from 0 to 2 seconds? मतलब charge flown in 2 seconds minus charge flown in 0 seconds upon T2 minus T1. So T2 is nothing but 2 minus 0. 2 minus 0. Understood? Delta Q is charge flown in 2 seconds minus charge flown in 0 seconds. Charge flown in 2 seconds means just substitute charge में substitute करो. So 4 plus 4, 8 minus charge flown in 0 seconds. 0 लगा तो 0 आया by 2. So 2 to 4. 4 ampere is answer. How the video? Chal. Now charge in terms of time is given. You found directly differentiating. Okay. if I given current in terms of time and I'm telling to find charge, how to find current in terms of time is given? I want to find charge.
Integrate.
Huh?
You integrate. You integrate. Um,
In bolo.
I I dt
Suppose
is
I
equal.
given like this: I is equal to t square plus 2t. I want charge.
So you do I is equal to dq by dt, and then you send dt that side. So it'll be I uh, dt, and then you integrate it on both sides.
Correct. Very good. Khadam. Dekho. So for this के लिए, suppose current is constant, directly Q equal to IT will find current constant. तो अगर current varying है तो then only we can use this formula. This same thing. देखो I is equal. How you got this formula? I equal to dq by dt. Okay. Therefore Q is dq is equal to Q small q little. Okay. So dq is equal to I dt. I am integrating both sides. dt का limits are from t1 to t2. And either dq का integration is q. Therefore, q is equal to integral I dt from t1 to t2. Satik, you are there? Q equal to integral t1 to t2 I dt is the formula. इंटीग्रेशन फॉर्मूला याद है ना इंटीग्रेशन का इंटीग्रेशन ऑफ एक्स फोर एन कितना बोलो
x to the power n plus 1 divided by n plus 1.
n plus 1 okay so chalo and the integration of dt will be t right dt will be t okay chalo करो now देखो I in terms of time is given to you. He is telling to find the charge flown in 0 to 3 seconds. So when current in terms of time is given, how to find charge? Charge is equal to integral t1 to t2 I dt. And charge के units are coulombs, right?
$36 coulombs.
36, huh? Yes, correct. 2t dt. 36 आ गया शिवंग आपको में? Yeah. So integrate both sides. 3 बाहर आ जाएगा. Integration of t square is t cube by 3 plus 2 बाहर आ जाएगा. Integration of t is t square by 2. So 2 to cancel, 3 to cancel from 0 to 3, 0 to 3. So upper limit minus lower limit. 3 cube is 27 minus lower limit is 0 plus 3 square is 9 minus 0. 36 coulomb is answer. Okay. So always when current in terms of time is given, use this formula to find charge. Okay. Next physical quantity. We have to know about current density. We represent as J vector current density. Okay. So amount of current flowing per unit area around that point provided area is in the direction of current. देखो करंट डेंसिटी का बेसिक फॉर्मूला है करंट पर यूनिट एरिया एक स्क्वायर एरिया में कितना करंट फ्लो हो रहा है दैट इज कॉल्ड करंट डेंसिटी एंड करंट डेंसिटी इज नथिंग बट ए वेक्टर क्वांटिटी जे वेक्टर सो आई बाई ए वेक्टर ओके एंड जे इज इन द डायरेक्शन ऑफ करंट सी मान लो सो दिस इज अ कंडक्टर दिस इज एरिया ऑफ क्रॉस सेक्शन आई नो एरिया वेक्टर कैसा आएगा इसका एरिया वेक्टर फिल फर्स्ट चैप्टर में एरिया वेक्टर इज ऑलवेज परपेंडिकुलर टू सरफेस राइट सो दिस इज एरिया वेक्टर okay the amount of current flowing per unit area. So current is flowing in this direction. Okay. So current density is given by current per unit area, provided the area is in the direction of current. Always that is the important thing. This definition is hold true only when the area vector is in the direction of current. This is in the direction of current, right? The area vector is in the direction of current always. Then only this definition is true. Current per unit area is called current density. So area should be in the direction of current. And its units are ampere per meter square. Current per unit area, ampere per meter square. Okay. Suppose मान लो, if current is not perpendicular to area, suppose देखो this is the area vector, I is like this, area vector तो ऐसा है, I theta. Now in this case में can you tell me what is current density का formula? Current density का formula is
I cos theta by A.
I cos theta by A. No, current should be in the direction of area ना, area should be in the direction of current. In the definition में, in the definition में क्या दिया, area is should be in the direction of current, right? So current per unit area, current per area कौन सा रहने का, in the direction of current. So A का component क्या होगा, A cos theta. So when the current and area vector in the same direction, just use I by A. If not, you take the components, will get I by A cos theta. And theta is the angle between I and A. Okay. So definition आ गया ना, J is normally, whenever don't mention directly I by A you can use. Okay, I by A is a current density. So design purpose time में they will useful this one. Per unit area में कितना current flow है, उसके accordingly the cross section they will put. Suppose इसमें इतना current चाहिए बोलते, उसके accordingly they will put a cross section. Okay. Now tell me. Under steady state, मतलब current is constant. Which one is correct? This is A. This is B. So current steady state means current is same in both the cross section में, current is I only. Which means current density किस में ज्यादा है, क्रॉस एक ए में ज्यादा है और बी में ज्यादा है? Simple one.
B.
Huh?
B.
Is
B is more than A.
okay. Which option?
A B.
Oh, B is answer. Okay. See, current density का formula क्या है? I by A. Steady state means current is same. Both cross section में current is same. So it inverse proportional to area. So more the area, lesser the current density, right? So in this में आपको JA ज्यादा cross section है. That's why JA is less than JB. Inverse relation. That's it. Formula से आ गया, right? Sure.
So the area vector of A is not in the direction of current, right? Because it has to be radially outwards.
Why ऐसा है ना? Why radial outwards क्या? Area vector I can take any direction, right? Direction of current.
So
Area
for
vector
objects, it's usually outside though.
क्या? 3D surface हाँ.
Yeah.
3D surface थोड़ी नहीं है. I'm talking about this area के. Hollow मान लो, anything मान लो, cross section area. ऐसा.
Okay.
Area vector and I current will the same direction. Until unless you don't mention directly normal only. इफ दे मेंशन डायग्राम में दिया तो देखेंगे. ओके, चलो, these are things. Now we'll enter into the concept of drift velocity. Drift velocity. So drift velocity में आपको सम थियरिटिकल टॉपिक आपको समझ में आने का, उसका डेरिवेशन समझ में आने का. ओके, थोड़ा फास्ट फास्ट लिखो. डेरिवेशन समझ में आने का, ये पूरा कहानी ओनली, दिस स्टोरी ओनली पूरा. ओके, ड्रिफ्ट वेलोसिटी सुना होगा, नाम सुना है ड्रिफ्ट वेलोसिटी बोल के? वेयर? जस्ट नो क्लास में सर. हाँ, ड्रिफ्ट
Banking,
वेलोसिटी. हम्म.
banking of roads.
ओके, चलो देखेंगे. चलो, ड्रिफ्ट वेलोसिटी का सो एक कहानी है, थोड़ा स्टोरी फास्ट फास्ट लिखने का. देखो, ड्रिफ्ट वेलोसिटी ऑफ मेटालिक कंडक्टर्स, उसका मीनिंग क्या है पूरा ये थोड़ा समझ में आने का. इसमें थियरिटिकल क्वेश्चंस आल्सो दे विल आस्क, दैट्स व्हाई दिस इज थियरी इज इंपॉर्टेंट इन दिस. Okay. Metals have large number of free electrons, right? Initially, metals have large number of free electrons. कितना है? That is 10 power of 28 free electrons per meter cube. Example, per meter cube में इतना electrons are there. And उसको क्या बोलते हैं? Free electron density बोलते हैं. Number of electrons per unit volume को free electron density बोलते हैं. Okay. Now क्या है? In the absence of electric field, now conductor में, in metallic conductor में so many free electrons are there, right? These free electrons will be at rest or in motion? Tell me, these free electrons are in rest or motion?
Motion.
Why?
They keep moving.
Why it is moving? हम लोग नॉर्मल पुश किया तो क्या हो, थोड़ी देर के बाद रुक जाएगा ना. हाँ, साथ ही बोलो.
The collisions.
क्या कोलिजन्स? कौन पुश कर रहे हैं? ठीक है, कोलाइड होकर रुक जाएगा ना. जाएगा, हिट करेगा था मैनेज गेट लास्ट, बाद में थोड़ा इधर इधर आकर रुक जाएगा, सभी रुक जाएगा. चल भाई, कंडक्टर में हाँ.
So due to the charges,
Charges only, this only charges only. By motion or extra?
it should be in motion.
Motion. Why? Who is pushing? Who is pulling? क्या कौन है?
So like charges repels, they don't.
तो रिपल होके ऐसा जाएगा, रुक जाएगा, क्या जाएगा, फिर से आकर फिर से जाएगा, फिर से जाएगा, थोड़ी ना जाएगा, इधर जाएगा. ओके, सो क्या होगा? This, in the absence of electric field, means I am not applying any potential difference, anything. Okay, normal in this way, the charges are in motion because of surrounding temperature. Okay, surrounding temperature रहेगा ना, उसके वजह से it gains energy and start moving. We studied in the kinetic theory of gases में, the the temperature is nothing but the kinetic energy. So how much temperature, that much kinetic energy is moving. More the temperature, more the kinetic energy of the electrons moving. Okay. So in the absence of electric field, the free electrons move randomly due to thermal energies. लिखते जाओ first. And we know that kinetic energy is proportional to temperature. More the temperature, more the kinetic energy of electrons. That's why kinetic theory of gases बोल के first year पढ़ा. सो थर्मल एनर्जी से जो इलेक्ट्रॉन मूव हो रहे हैं ना विथ वेलोसिटी, दैट वेलोसिटी इज कॉल्ड थर्मल वेलोसिटी. वी कॉल्ड एज थर्मल वेलोसिटी. मतलब कंडक्टर में इफ यू सी नॉर्मली एनी वायर को ले लो, एनी वायर क्रॉस सेक्शन देखो, इफ यू सी जूम करके देखेगा तो इलेक्ट्रॉन्स आर मूविंग हियर एंड देयर, हियर एंड देयर. ओके, सम विथ सम वेलोसिटी. दैट वेलोसिटी इज नथिंग बट व्हाट? थर्मल वेलोसिटी, बिकॉज वी आर नॉट अप्लाइंग एनी एक्सटर्नल फील्ड. थर्मल वेलोसिटी, राइट? हो गया? कॉपीड?
So why is it? How does it have thermal energy? Why does the conductor have thermal energy?
हीट दिया तो क्या होगा? इलेक्ट्रॉन स्टार्ट
So
मूविंग.
we're providing heat to the conductor.
सराउंडिंग में हमारा घर में कितना टेम्परेचर है नॉर्मली? सम डिग्री 30, 20, 26 होगा ना. दैट इज ओनली सराउंडिंग टेम्परेचर. और सराउंडिंग टेम्परेचर में ऑलवेज ऑल मॉलिक्यूल्स आर मूविंग. सी वाटर में वाई मॉलिक्यूल्स आर मूविंग, पानी में एनीथिंग टोटल में वाटर मॉलिक्यूल्स आर मूविंग. वाई? बिकॉज ऑफ थर्मल एनर्जी ओनली. इफ दे, दैट्स व्हाई सर्टेन टेम्परेचर में at which the molecules start stopping the motion. that is called as 0 Kelvin. ओके एब्सोल्यूट जीरो बोलते हैं. एब्सोल्यूट जीरो में द मॉलिक्यूल स्टॉप मोशन, दैट टाइम कुछ भी मूव नहीं होगा. ओके, बट बिकॉज ऑफ थर्मल एनर्जी डेफिनेटली द एनर्जी इलेक्ट्रॉन्स आर मूविंग हियर. ओके, नाउ by kinetic theory of gases, the thermal velocity of the electron at room temperature is given by formula under root 3 kT by me. This thermal velocity का formula है. Kinetic theory of gases में we studied. Under root 3 kT by me. K is Boltzmann constant, T is temperature, and m is the mass of the electron. If I substitute this value in this, we will get thermal velocity is approximately 10 power of 5 meters per second. Okay, that means utna fast. 10 power 5 is not a small number. It's like approximately 1 lakh. 1 lakh meters per second it is moving here. Zoom 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 बोल के because of thermal energy. उतना speed में जा रहा है. But not moving from one place to other place. It is moving around itself only. Atom के चारों तरफ घूम रहा है. Okay. Now suppose मान लो U1, U2, U3 so on to UN be the thermal velocity of different electrons. एक electron is moving in different direction, right? This is moving with U1. This electron is moving in this direction, U2 vector, and other electron is moving with some other direction, U3 vector. So now इसका average velocity कितना होगा? If I add all the average velocity for this vector में कितना होगा? It is 0. The average thermal velocity of all electrons is 0 since different electrons move in different direction. देखो इस electron is moving velocity इस तरफ and दूसरा electron will move in the exactly opposite direction. So vectorially it is 0. दोनों equal and opposite vectors क्या होगा? Cancel out each other. ऐसा पूरा millions of electrons are there. All cancel out के उसका thermal energy. If I talk about the U average will be U1 plus U2 plus U3 plus so on to UN by N. Vectorially, if you add, so it is becoming 0. That's why there is no current without any external electric field or any battery. Normal wire may, if you see, even the electrons are moving here and there, but not moving forward. Okay, that's why there is no current. If there is a charges motion, there is a current, there should be current. So there is no current because average velocity is 0. That means I can tell like this, there is no net motion of electrons in any particular direction in the absence of electric field. In the absence of electric field, there is no net motion of electrons. The electrons are not moving from one place to other place. ये पूरा डेरिवेशन में यूज होने वाला है ये सब कुछ. ओके, नाउ मैं क्या करूंगा? नाउ अप्लाइंग एन एक्सटर्नल इलेक्ट्रिक फील्ड by connecting a battery. Okay, now I took a conductor initially. Before I did not connected. Now I connected with a battery. When you connect it with a battery, there is a potential difference. Definitely there is an electric field from positive to negative. Electric field is there. तो कनेक्ट करने से क्या होगा? electrons experience an electric force in the direction opposite to direction of field. याद है ना, electric field इस तरफ गए तो electrons are moving in the opposite direction with some force, that is QE. याद है ना, so electrons are moving in the opposite direction that of. So at that time what is the force will be? F is equal to QE. Okay, and F is equal to Q के जगह में E I am putting, charge of electrons is E. When you come to the vector form में लिखने समय you have to understand that electric field इस तरफ है, force acting is opposite direction. That's why I am putting minus here. When you write in vector form, since electric field and force are in opposite direction, it is minus EE. इतना force act हो रहा है when you apply an battery, when you apply an external field, इतना force act हो रहा है on the electron. उसके वजह से क्या होगा? When there is a force, definitely there is an acceleration. And acceleration कैसा आएगा? Acceleration is equal to force upon mass. And force already you know, minus E by M. This is acceleration acting on the electron. So when I connect with a battery, there is a force, and because of force, there is an acceleration of the electron. Okay. Acceleration is there means whether velocity is increasing or decreasing. Velocity is increasing or decreasing. Follow?
Increasing?
Increasing. But in this chapter, I told you that electrons will move with a constant velocity, right? Constant speed. Then only current electricity. Otherwise, magnetism come into picture, right? So then why it is not happening means क्या होगा? आपको लग रहा है कि acceleration act होगा, electron zoom बोल के fast में every second the velocity will increase बोल के सोचेगा, okay? But that is not happening. Why? Because देखो, okay, now it seems that free electron move with a constant acceleration this much and increasing velocity in direction opposite to the direction of electric field, but this does not happens. Okay, why? See, as the acceleration, as the electron accelerates, because it want to accelerate, they frequently collide with the positive metal ions or other electrons and stop momentarily each collisions and start fresh again. देखो, कंडक्टर में so many free electrons will be there, right? So many free electrons will be there. जब इलेक्ट्रॉन जब इधर से एक एटम में से निकलेगा, this will become ion हो जाएगा, metal ions will be there. Now this electron when it coming, it want to accelerate, वो जाकर क्या करेगा? हिट करेगा metal ion, वो रुक जाएगा, momentarily stops. Again because of फिर से force acting हो रहे, again it want to accelerate, again it stops. Again ऐसा ऐसा stop करके normal constant velocity से जाएगा, सभी electrons constant velocity से जाएगा. That velocity is called drift velocity. All electrons move with a finally constant velocity. That velocity is called drift velocity. Okay. So देखो example, देखो इन कंडक्टर में सपोज मान लो कंडक्टर में द इलेक्ट्रॉन इज मूविंग, ये इट वांट टू एक्सेलरेट बट जाके मेटल आयन को हिट करेगा, मोमेंटली स्टॉप हो जाएगा. अगेन इट विल गो समवेयर हियर एंड अगेन हिट करेगा, स्टॉप हो जाएगा. इट विल मूव इन zigzag मैनर बट इट बाय ड्रिफ्टिंग फ्रॉम वन प्लेस टू अदर प्लेस. नाउ इलेक्ट्रॉन स्टार्ट मूविंग फ्रॉम वन प्लेस टू अदर प्लेस, that with some velocity, that velocity is called drift velocity. That velocity is called drift velocity. तो ये जरूरत नहीं, ये लिख लो. As electron accelerates, they frequently collide with the positive metal ions or other electrons and stop momentarily on each collision and start fresh again. डन ना? Okay. So now इसका देखो, the acceleration occurs only for a short interval of time between the two collisions and provide a small velocity to electrons in the direction opposite to the direction of electric field. This velocity is called drift velocity. So it will move with a constant velocity, which is called drift velocity. Definition लिख लो. The average velocity of free electrons with which they move in a conductor under the influence of electric field. ये लिख लो बस. The average velocity of free electrons with which they move in a conductor under the influence of electric field is called drift velocity. Because electron is not only one, right? सभी electrons का average if you take velocities का, that is called drift velocity. तो उसका अभी कैलकुलेशन पार्ट नेक्स्ट क्लास में करने वाला है.